Welcome everyone. So yeah, today is very unusual day because we are streaming not on weekend but apparently on is it Tuesday today? It's Tuesday today. So we are streaming on Tuesday. Yeah. And that's why because yeah, recently we got quite a large amount of new people. So yeah, don't forget please to subscribe on Telegram and on Instagram because all the updates, insights, Corpo Live, Microsoft is going to be there, right? So let me just leave the link. You can find everything you need, I guess, by this. Yeah, and we already have a bunch of chat messages, which is quite unusual. So yeah, let me actually jump into the topic. So what is the plan for today? The plan for today is, as was announced in Instagram and Telegram, by the way. Don't forget to subscribe. So the plan for today is to solve LeetCode problems. We are doing this LeetCode 75 questions, and we eventually got to dynamic programming. And today we're gonna solve a bunch of dynamic programming questions, and we're gonna learn how to create a recursion, notice the subproblems pattern, then how to do top-down memoization, then how to convert top-down to bottom-up, which is pretty much most interesting question. And then how to optimize bottom-up even further with the optimized space. So yeah, for those who just joined, yeah, I'm Andriy. I'm already 7 years in IT industry, and 3.5 last years I'm working for Microsoft in Prague. Today, unfortunately, we don't stream from terrace, we don't stream from the office because it's terrible weather outside, it's raining in Prague. In general, I guess this year's summer is not the best summer, but at least it's not that hot to sleep during the night. So, yeah, quick chat sync. So yeah, and also I would like to put here a plan. So we're doing dynamic programming questions. This is first one. We can do, if you would like to check something on the LeetCode, we can do it, but please don't put some really hard problems with I don't know, submission rate 20%, because yeah, I don't think you want to see me struggling for half a year doing some bullshit. So yeah, in general, yeah, for quite some time I was doing interviews at Microsoft as interviewer, and also I was passing a lot of interviews as interviewee as well. So yeah, and after that we're gonna check system design concept, because I need to recall something. Actually, what we're gonna look for is consistent hashing. Some time ago I actually was implementing consistent hashing, and it was actually reviewed in my article. So how is it implemented? I actually did it and set up locally on the Docker containers, so you can check. What I want to do now is to recall it formally and to do some kind of POC and add it to our repo in GitHub for distributed system solutions as a kind of pattern, because consistent hashing is pretty much one of the simplest and one of the best solutions for sharding problems. So whenever your interviewer during the system design asks you, okay, you got a lot of data and a lot of requests, so how are you gonna split the data? You can say, okay, I'm putting read replicas, and the interviewer says, okay, but you have a lot of writes, and then you can say, okay, since we have data, we can get a hash of the key, and after that, then yeah, so people are asking for the link, and this is the link for repo, this is the link for article in case you're interested. I would post it again in Telegram later on, right? So yeah, back to the consistent hashing. So once you say to interviewer, okay, I might use some hashing, then how you're going to use your hashing, right? You can have 4 instances, let's say, and you can use mod operator, which is pretty much one of the best. So what you can do is just to do a hash of the key mod number of instances. But this approach is very bad because you cannot actually scale more instances. If you think about it and run through some of the examples, if number of instances was, for example, 5, right, and then you want to add another instance, and now all your sharding works as following, and you need to reshuffle a lot of keys between the instances, which kind of worst case can lead you to the situation when you basically moving all your data that you have in your cluster, whole cluster between the instances, and it increases load, it increases CPU and stuff like that. So that's why you need consistent hashing. That's why you need to understand the concept, because this is pretty much one of the basic and most useful patterns for the sharding approach in the system design problems, right? So this is the plan for today. Let's see how we're gonna proceed with that. And yeah, today is extremely a lot of people here. Is 20 people watching us out there. Usually it's 10. So yeah, thank you. Please don't forget to subscribe. First YouTube, second how this thing is called, Twitch, and then Telegram, especially Telegram, because all the updates, everything is there. So question, hey man, do you think focusing on Java is still viable in 2025? I got a good job offer as a working student for my last 12 months. Good chances for a follow-up position, but it is in full Java and ERP. I'm not sure what is ERP. What is ERP? Oh my God! Please Google. Don't do this check based. Okay, what is this? Enterprise resource planning. Okay, I have no idea what is it, but Java in general, I don't mind Java, right? I'm personally .NET guy, so I would prefer .NET for sure, because my personal opinion that .NET overperforms and overcomes Java for past 10 years since it started being .NET and being available on Linux and on different operating systems. Before that, while .NET was only for Windows, yeah, .NET sucked a lot, and I would prefer Java as well, 15 years ago for sure. But in general, what I can say that previously in my past experience, I was applying for a couple of financial companies, for example, like Revolut, Wise. And the rejection reason was that I don't have Java experience. So definitely Java is here, Java is on the market, and Java is not that bad. It's easy to switch from Java. Hey cat, oh my God. Okay, sabotage. So yeah, there are quite a lot of positions for Java, and I don't think Java will be dead anytime soon. First PHP should die and then Java, so you should be good. Especially if it's your first job, it should be quite good. You can switch from Java to anything you want. Like, it's not that hard to switch from Java to Python to JavaScript to .NET and stuff like that. Yeah, as far as I know, Java means you can always find a job. I would kinda agree with this statement, yes. Hey there, sounds good. Okay, just curious, how old are you? Well, guess. Can you type in the chat what do you think? How old am I at the moment? Like, what is my age? I kind of gave you a hint, small hint, but yeah, I would be interested. How do I look like? I hope I look like 20 or something. Okay, link I provided. Yeah, no problem. Can you adjust font size a bit? Yeah, of course. And what is wrong with font size? Should I increase it or decrease it? What the hell is this? Let me actually check on Twitch. Yeah, of course, yeah. I think this should be much better. I hope, like this, for example, right? Yeah, I hope it is better, but yeah, good. 27, 28. Okay, good. Look, 24, lol. Yeah, I'm 25 right now. But assuming your experience, you're older, like 27 maybe. No, I'm 25. I started at 18. 18 was my first commercial experience in company with size of 100 people. So yeah, hope the font size should be okay at the moment. And this one I'm gonna increase a lot as well. Okay, so I guess, hey bro, are you new to LeetCode? Well, I wouldn't say that. Not quite new. For a couple of years I'm here. Yep, thanks. Okay, good. So, people all around the world, let's start our dynamic programming stuff. So this we're gonna leave. And previously, yeah, we just solved this easy problem, which is Fibonacci number. Actually, it's Fibonacci, but with just additional calls, so pretty much easy. Let's do this thing. So, mean cost climbing stairs. So what the problem asks us to do. We are given integer array cost, where cost of under index I is the cost of ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or step with index 1. And we should return the minimum cost to reach the top of the floor. Since it's easy, I guess brute force should fit here. Well, I don't think brute force will fit here. But yeah, this is typical dynamic programming question. And why so? Because this is pretty much easily can be split on the problem. You should basically try to think always about definition of your recursion. So first of all, for typical dynamic programming question, the easiest way you should start with is to define a proper recursive function. It should be brute force for the first time. And what you should try to do, you should try to minimize the input parameters, and you should make your function to return something. So your function should be something like kind of pure function in a way that call it whatever you want, that got some parameter and returns some value for this parameter. So this function should solve your problem for parameter 1 and return the result for parameter 1. This is what you want to do. So actually what we want to do, how many steps do we have? We have lengths of array steps out there, right? And how this can be split to the sub-problem if we draw it. So let me actually draw it a bit. No, I think better can be done with this guy. Good. So we can start either from this index or from that index. So this is going to be our start point. And whenever we start, we have actually two choices, right? We can climb 1 or 2 steps. So if we start here at index 0, we can basically climb to this index or to that index. And then what we should actually calculate, we should calculate how many, what is the minimum cost starting from these two indices. So from first or from 2. We should calculate both of them because both of them might give you the minimum number of steps, right? So if we start from 1, for example, we can go to index 2, which we already kind of stepped beforehand, or to index 3. Same thing happens with this index. If we stepped index 2, so we follow this path, we can now step at this index, index 3 or index 4. So if you draw the call stack function, what you will be looking for, you can kind of check. So let me actually program it. It's not that hard. So let's define our function as get minimum cost for starting from index int. So we have our parameter and we define our function as the function that's gonna return us the minimum cost if we start from index int. We're gonna start as defined from index 0 and from index 1. So in the end, what we want to return is minimum of call of this function from index 0 or from index 1, basically. And what the function gonna do, first of all, since it's gonna be recursive function, we want to define a base case. So if index is more or equal than cost, like cost, we should return 0. Why? Because cost of stepping when there is no any more steps is 0. We don't have to pay anything. We are already done, right? Then, if we are on some stair, the cost of jumping from this stair is exactly the value under this index. So, how we're going to define this is to return get minimum cost of index, get minimum cost of index plus 1, which simulates the step one step further. Or let me define this one, minimum result. This one, so we should actually choose the minimum from both of them. So we either step 1 step forward or we step 2 steps, which is going to lead us to index plus 2. And then we should also include our current cost, because whenever we are at some step, we should pay the price of cost i's. So what we return, the minimum of both of these two subcalls plus cost of index. We cannot go out of range because this prevents this. This check should be great. So actually that would be it. And again, we did just first step of our basically any dynamic programming question. So first of all, don't put your response as an input parameter. So what you don't want to do is to put current cost over here, which is pretty similar to what you're going to do in the backtracking problems. What you want to have some number of input parameters which actually defines your subproblem. So input parameter should define your subproblem, and the return value from the function should be result for this subproblem. And this is how you're basically gonna proceed. So should it work? Let's basically perform a dry run and see if it works. Yeah, it works. And now let's actually analyze what would be the time complexity and space complexity, because yeah, our constraints are pretty low, I would say, but still we have 1000 elements. Maybe it might be something bad. Let's get back to our function. So how our call stack would look like. Yeah. So this is, let me just adjust the chat a bit, just a bit. Yeah, so what would be our call stack? We might start from 0 index or from 1 index. And we actually gonna initiate both of these calls. Then, from 0 index, we can basically step to index 1 or to index 2. Then from index 1, we can step to index 2 or to index 3. Then from index 2, you can step index 3 or index 4. And consequently, from 3, it's going to be the same, 4 or 5. And from index 2, it's going to be 3 or 4, and so on. Okay. Hey, Microsoft, why you don't work? Okay. Never mind. For index 1, it's going to be exactly same situation. So index 1 might lead you to index 2 or index 3. So 1 step or 2 steps. And it's going to be actually same as this sub 3. So let me even change the color. So this guy would be exactly like this guy, the whole sub 3. So we're first going to call this function. It's going to be, I think, kind of pre-order traversal in terms of how call stack would grow. So it go the leftmost leftmost way first. So it's gonna spawn this call, then this call, then this call. And in the end, we're gonna calculate value for index 3. If let's say the index 3, okay, it might not be the last, but whatever. At index 3, we're gonna start returning value, and after that, we're gonna check index 4, and this is going to be our call stack. Kinda like, or is it in order? Yeah, I guess it's in order kind of traversal, but it's not clear what is meant by visiting the node. Anyway, so at some point we're gonna reach this node and we're gonna return the value for the index 1, right? But then after that, we're gonna start another call over here, right? And we're gonna again traverse and do exactly the same steps, exactly this big call stack gonna be spawned on our thread, right? And if we put pretty large enough number, we can see that every our function call basically spawns 2 more function calls, like sub-functions in this case. So the time complexity in this case will be pretty bad, because let's say we have 4 indices, every index or every function call for this index is going to spawn 2 sub-function calls. So it's actually 2 times 2 times 2 times 2, so 4 times multiplication of number 2, which actually translates to 2 to the power of 4, or otherwise 2 to the power of n. So in case of having 1000 elements, it's going to be 2 to the power of 100, and this is actually a pretty huge number. If we do, how is it in, yeah, so 2 to the power of 1000, yeah, it's very huge number. So this is quite a big number of calls, and it's not a good time complexity. So how do we proceed with this? How do we solve this problem with the time complexity? So this is kind of step 1. We already did it. Define proper recursive function that solves sub problem. Next thing, we have very bad complexity. So time complexity here is going to be O to the power of 2, oh sorry, O or big O of 2 to the power of n, which is quite bad time complexity, I have to say. This is quite bad. For the space complexity, how can you think it can be, what can be the space complexity here? So our call stack is going to be space complexity here, and we go all the way down to the last node, and our last node can be basically, at maximum it should be last index, right? Because we proceed until we reach the end of the array. So basically this is going to be the height of this tree, and this is going to be O1, because maximum number of these elements is size of the array, which is O1. So space complexity in this case is going to be O1. Now, how we gonna improve the time complexity, which is very bad here? So first thing that you can do in Python, it can be done just by applying this decorator or whatever it is called. I'm not Python expert, unfortunately, which gonna basically cache each of these calls, but let me actually extend it to something different. So instead of recalculating every single index for so many times, because you can see the repetition. Here we have index number 3, here we have index number 3, here we have index number 3, so we're gonna do quite a lot of same computations. And if this index 3 actually then spawns, I don't know, 1000 more, it means every single time we're gonna do 1000 calls, right? And this is very bad. In order to not do this, once we computed index 3 here, we don't want to computate it anymore. So we can just somewhere save the result for index 3 and reuse it subsequently in all our subsequent calls. Same can happen to index 2, which gonna be used here, with index 4, which can be used here, and so on. So basically every time we calculate some result for index, we put it to some kind of memory. And again, in Python it's done very easily. You can just put cache decorator. I will show you that it's gonna actually work here. So yeah, it is accepted, but actually LeetCode gonna throw us time limit exceeded at that point because yeah, 2 to the power of 1000 is very huge. So it will be time limit exceeded for sure. And then I'm gonna demonstrate how it's gonna perform with the cache decorator. Yeah, again it works, and let's submit. Yeah, and this time it passed. Not the best, but it passed. So for any other languages, how it's gonna be working, so you can put either hash map here. So one way is just to put some cache as a hash map, which is more unique way comparing to arrays, but what you in the end want to do, you want to use not a hash map but array instead, and I will tell you why in a bit. So in case you decided to choose a cache, your key for the cache would be whatever you have in your input parameters, and again in Python you have tuples, so even if you have 2-dimensional, 3-dimensional, n-dimensional dynamic programming question, you can put key as a number of this parameter 1, parameter 2, and so on, and just put it to the cache. And on the each function call, you're gonna check if index, in this case our key, we don't need to put it into tuple. If index is inside the cache, in this case we return cache index. Otherwise, if it's not in the cache, I would define a result here, right? And I would put cache index equals this result, and then return result. So next time it will be in the cache. So let's try to run it. Exactly, it works, and submission it will also pass pretty much same complexity because it's, yeah. Not the best one, but anyway, at least it's now better. But what is the time complexity? So now, this is step 2 already, and step 2 is to convert add memoization, which is pretty easy step. Because what you should do, you should just do these 2 lines, and it will work. It will work because it's pretty easy, right? It's pretty easy. Just put some caching. And what will be our time complexity at this point? So let me go back to our tree, and let's assume we have 5. Our last index is going to be 5th. So in a nutshell, we have 6 elements, right? So how the tree gonna be looking like? So it's gonna be 4, or maybe, yeah, it's gonna be 4, it's gonna be 5, it's gonna be 5, and this one will return 0 already as our base case. This guy gonna be 5, this gonna return 0 as well. So it's gonna spawn, oh sorry, just return here, right? Yeah, so these 2 gonna return 0, and we return, yes. So this guy will not spawn any more calls, or I mean, it will spawn, but they will be kind of dead calls because they're gonna be the base case. So I would draw them as a non-existent ones, right? So this 4 gonna define this guy. Pretty large for the 5 elements, by the way. And same gonna happen for index 2. I'm not gonna draw all of the right subtree, right? Just a bit of elements. So again, these 2 like this. And 4 is gonna be spawned to 5 and base case. So how it will work like? Since it's recursive function, we go kinda in order or pre-order traversal. We go leftmost as much as we can. We reach this guy, then we reach this guy, then we calculate it for 5. We put 5 in our hash map, so 5 is going to have some value, no matter what, I mean, like value 1. Then we reach out 4, we go to the right subtree, we calculate to 4, we save it to cache. So 4 is going to be some value 2, no matter what is the value. Same happens for 3, but for 3 it's a bit different case at that point, because 3 would spawn actually the next one, it will go 2 stairs ahead. Hey everyone who just joined. So at step 5, we would go and check our hash map, and we return straight away the value from the hash map because we have it already in our hash map. So that's it. For index 2, we step here to index 4, but we have it in our hash map, so we just return straight away. So we kinda, in a way, throw away all the calls that are on our right subtree. So all these branches, this branch, that branch, that branch, they will not be computed anymore because of the caching. So in a way, and also these two also will not be computed in this branch. Why? Because it will be computed on this step. So in the end, we can clearly see, let me also return it from, change the color and highlight it. So in the end, our call stack will look like this, and we're gonna just traverse the leftmost branch of our tree, and all of these guys, they are not spawning anymore. So what is the time complexity in this case right now? I think it's exactly the same like our space complexity, because we're just gonna have at the maximum the depth of our tree, and depth of our tree is linear, it's O1. So now our time complexity changed to O1, which is great, but why the runtime is still so bad? Well, the runtime is so bad for a couple of reasons, and first reason is that every function call is actually more expensive than iteration, for example. What are other drawbacks of this, except the speed? So the speed is much better, but it can be even more better. So other thing that makes this solution bad, and what you actually can be asked during your interview as a follow-up question, is this is still a recursive call, right? So we actually don't want to have recursive, because for the big number of input, you might get Stack Overflow, right? So we are more limited with this. It costs you more in terms of everything, basically, because you need to look up this method or function table. You need to spawn one more thing on your call stack, which is much more expensive than just one iteration, right? Which also can be optimized by CPU, right? Or sorry, by compiler. Yeah. So how we can overcome this, and how we can change it from the recursive to iterative approach? And this is pretty common question on your interview, like how do you change the recursive call to iterative, or recursive approach to iterative approach? There are quite a few methods. So for example, you might start with emulating the stack. You might start with emulating the state machine in some sense. So it depends on the problem, but for dynamic programming, it's much better. So what we do, actually, instead of going from the top to the bottom, we kinda change the direction of our flow. And for this line, we just start from the base cases and move it upwards to our initial value that we asked for, maintaining this hash map or whatever it is, array, whatever, some cache. And in the end, we just return this last value. So time complexity remains the same, but what is better, what will be better in that case, that we are going to have iteration over recursive calls. It will be faster, and it will be iteration, so we have less limitation. How do we do that? So first of all, caching is not that great here. It will be much better to change it to array. So instead of cache, since we know how many cache items and what our cache keys can be, so our cache keys can be only our indices, right? Nothing else. So we can basically put these lengths or lengths of post array and initialize this as our cache and put a 0 as default value, which is kind of true. Now, you can clearly see that our function call, it goes from index 0. In the end, it finishes with our last index, which is 5. So we also reverse it the same way to make it bottom up. That's why it is called as a bottom up, right? So change to bottom up. So right now what is going to happen is that we are going to traverse it exactly the same way as our call stack. So we start, as I told already, with the last index up to our first index. So I will even leave the same variable name. So for index in range, in reversed range length cost. So we're just reversing our indices, and we will start with index 5. And how it's gonna work, that actually we can now, for simplicity, and usually it's gonna work. For simplicity, we just copy paste the code here. I will leave it here for you to compare. And then we can just a bit change it, and instead of calling recursive function, we're just gonna call our cache values because they're gonna be already cached. So how it's gonna work? So if index more than length, we return 0. This cannot happen because we start with the length cost -1 here. So this clause is not possible to happen here. Right now, since we start with length cost -1, and we might want to see index +1 and index +2, which is going to be +1 or +2. So in the end, it can be something like this for our index. We can initialize our array a bit bigger only for this purpose, to not catch these specific cases. So we just add in 2 values. I guess it should be enough. Yes, it should be enough. And now what is going to happen here? This in cache we just don't care anymore. Now we return it. Sorry, we remove it. This cache, let's remove it as well for now. Let's focus on our core behavior here. So as I told you, what is going to happen, instead of recursive subcalls or recursive calls, we're going to use our cache with exactly same parameter. So as you can see, index +1, index +1. Because we already computed it, we don't have to recompute it again. And here we also put the exactly same parameter, but instead of function call, we put our cache. And now, yeah, we still need to put it back in the cache, so subsequent iterations can use the value. So for current value, cache index equals result. We don't return anything because we need to iterate first. What we do return is we return our initial call. So we also copy this, and also exactly same way like we did with this guy. Instead of function call, we just put cache call with the parameters, same parameters as they were for the function calls. And that's basically it. It should actually work. Yes, it works. And let's check the complexity. Now it should be a bit faster, but not due to complexity, but due to this optimization that we changed function calls to iterations and stuff like that. Usually for your interviews, that would be it. You already did a great job, because most interviewees, from my experience, it's very hard for them to convert the top-down to bottom-up approach. Because yeah, I agree, this is not the easiest task, especially for some specific dynamic programming questions. But there is even step 4, which you can get from your interviewer, which sounds like optimize space complexity. You can notice that actually every single iteration we just use 2 previously calculated values, and we don't care, like if it's, I don't know, it's already, we have 1000 elements, and this is index 5, we still are interested in index 6 and index 7. All 1000 elements that we calculated before, we don't actually care. So even subsequent optimization here would be to change it to these 2 variables. And this would be, I don't know, previous, or I don't know, yeah, previous one. It's ugly, it's pretty much ugly. So let's do step 1, because this is basically means step 1 result. Initialize it as our default value in the cache. There's going to be step 2, also initialize it as default value in the cache. And here what we do exactly the same. So step 1 means index plus 1, step 2 index plus 2. And then we just basically change it. Step 1, step 2, yes. And instead of cache, because we are not going to have any more cache, let me remove it. So instead of cache, what we should do, we should just refresh our variables so they can be they are slicing along with our index, and they are always here to help the calculation in a way. So what we do right now, so let's say we had this situation, we have 0, 0. Now we entered the for loop here, right? And now we calculated result, and our result should actually change. And now I don't know, let's say result is going to be something that our cost means, so it's 20, right? So result is going to be 20. And now what we want to do, we want actually to shift our two previous values to the following. So we leave it as it is, and now we should put current value as 20, previous value 0, and previous before value, so step 2 is going to be this one. So now we want just to shift these two to these two. And how is it done? Pretty easily. At step 2 is going to be equal to step 1 at the moment, and step 1 is going to be equal to currently calculated value. And we don't need cache anymore. And at this point, the last thing we want to return is the minimum of these two. And that's basically it. And we're gonna analyze the time complexity a bit later. It works. Yeah, and now this is pretty much the best we can do here. So this step is done, and this is basically fully solved dynamic programming question at this point. So what is the time complexity? So time complexity remains the same. We have a loop that traverses or goes through all the elements, so it's linear. But space complexity, as you can see, we're only using two constants, which are O of 2, and in the end it's going to be O of 1, because it's big O notation. We don't care about constants. That was it, basically. This is how you're going to approach the dynamic programming question. And let's move straight away to the medium one, the next one. It was kind of introductory, easy question for you to kind of understand the concept. And now I'm going to proceed a bit faster. So, house robber. You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So, I would translate basically this question in order to simpler and more computer science based words. So what we want to do, actually, we want to get as much as we can money from the house. So we want to rob and to get as more as we can. We don't know all the houses, right? So it's definitely not a greedy problem, because it might be that, our constraint here is that once we rob, for example, house number 2, it means we cannot rob house number 1 and house number 3. And once we rob, for example, house number 3, this one, or under index 2, whatever you want, we cannot rob 1 and we cannot rob 2. So here the best possible way for us would be to rob first house, then to rob third house. Second is not possible to rob, and first is not possible to rob. This is kind of the most efficient strategy. But can we do it greedily? We cannot, actually, because any subpass, any option that we choose here, any decision, might go actually to not the best result. So it can be situation. So one of the greedy approaches might be that we just choose whatever we can, the biggest values. So it can be, let me draw the same example. So in this case, do we want to start from 1 or no? Well, we want to, oh sorry, we have basically two choices here, I guess. 1 or 2. So we can choose house 2 because it has more money, or yeah, okay, this will be actually a bad example, but let me actually draw a bit different example. So it can be 3, and let's say 4, 2. Will it work that way? This is gonna be like this. Yeah, so this is the example. Imagine we want to do it greedily and we start just with maximum number all the time. So we're gonna start with number 4 and rob this house. So our sum is gonna be 4, and then since we cannot rob 2 adjacent ones, what we can rob is only this house, which is gonna be just +1 equals to 5. But instead, what we can do, we can rob house with money equals to 3. Then it allows us to rob this and that because they are not adjacent, so we add +1 and +2, and in the end it's going to be 6. So definitely the greedy approach won't work here. We want to explore all the decision tree that we have. So since that, it is pretty much dynamic programming question. Even more specifically, it's kind of knapsack problem. So at every single kind of step, we have two decisions, whether to proceed with the next house or to skip it. And we basically gonna express this in our code, and let's quickly define our recursive function and add memorization on top. So what our function should signalize us is that whether to rob the house at current index or not, and or even not that. So what would be the maximum amount of money we can get if we rob and when do we start actually? Professional constraint robbing each. We can start anywhere, right? So from index int, if we start from index int and we do our decision, what would be the biggest amount of money we can rob following our constraints? So in that case, what do we have? Like first of all, let's define the base case. So if our index more than or equal length of our array, of course we're gonna just return what is the maximum amount of array when we don't have houses anymore. It's basically 0, I would say. Then what options do we have staying at index int? So our maximum result would be it would be, so we can take the money from current house, right? So it can be nums index. This is the money from current house, and in this case we only are allowed to get maximum from the house after, because the next house is going to be adjacent, so we're gonna skip it. So it's gonna be index +2, because index +1 is an adjacent one. It's according to our constraints, we cannot do this. So this is gonna be one optional, let me name it take, because we are taking current, and proceed, or not take option, which is going to be we don't rob current house, but we now can allow ourselves to rob the next house, which is index +1. Then, since we need to do this choice and we can choose only one of these, we return maximum of take or not take decision. And then we return get maximum from index 0, because yeah, it might be we don't want to skip index 0. Now, yeah, let's actually run and make sure it works. First of all, yeah, it works, but it will be time limit exceeded. Again, why? Because we're gonna have same problem. Our time complexity, okay, we actually have only 100 elements, but even 2 to the power of 100, 100, yeah, it's gonna be quite a huge number, I would assume. Yeah, so it's time limit exceeded. Why so? Because at every single step, take a look. We are doing we actually spawn 2 recursive calls on every single recursive call function. So for every function we spawn 2 subfunctions, and each of these 2 subfunctions also gonna spawn 2 subfunctions each. So what it means and how our complexity would look like in this case, let me just quickly draw it. So we are at index 1, we're at index 0, and we can basically do 2 choices, take or not take. If we take, we go to index 1, if we don't take, we go to index 2. Then this guy is also gonna spawn like not take, gonna go to index 2, and take gonna lead us to index 3, and this guy 3 and 5. So actually our call stack looks pretty much the same like it was looking in the last problem, and we're gonna optimize it exactly the same way, so we can put memorization on top. It will lead to O(n) time complexity from 2 to the power of n. It goes to be optimized because we are basically removing all the right subtrees, and we taking a look only into this kind of leftmost branch. So it's going to be O(n). And now let's basically perform a bottom-up solution. So exactly same way, we're going to have our cache, which is going to be initialized with some default values. And you can see we exactly have same situation, because from the current index we can go to index +1 or index +2. Therefore, we're initializing it to length of nums +2. Default case is 0, so we're gonna be good. And now we're basically creating our for loop, reversing the call stack, and now we're pasting exactly the same that we have here, but we don't have this base case. At this point it's not reachable because index will be always less than length of nums. Now, as we agreed before, now all subsequent recursive calls we're just gonna replace with same parameters, but accessing our cache variable at this point. So look here, this is index +2, and this guy gonna be cache index +1. And yeah, let me not remove it actually. And we also want to memorize it because next time we're gonna reuse this variable for subsequent indexes. So we're just gonna put cache for the parameter index is this guy. And then we return cache index, for example, like this. Sorry, not return. Sorry, we don't return from for loop anything. We just return then this guy. Again, we're changing a recursive function call with the cache access, and same input parameter, which is 0. Now it's gonna work basically. It's pretty much. Oh shit! It's not gonna work. Yeah, sorry. It's pretty formal and standardized, I would say, templated approach how to transform top-down to bottom-up. There are some dynamic problems that might actually involve a bit deeper thinking of how to translate top-down to bottom-up. But usually it's literally you just define some good recursive function, and then you just copy-paste everything you have, and you change the recursive subfunction calls to accessing to the cache access basically. And that's it. Now let's submit and see our time complexity. Basically time complexity didn't change. Space complexity didn't change either. So time complexity is going to be O(n), and space complexity is easily spotted. We just do for loop over nums, so it's going to be O(n) as well. Now, space complexity optimization, step 4. Hello, welcome everyone. Immediate sub cause you wrote cache and not DP. Yes. Yeah. This is actually very, this is a very good point. I hate when people are writing DP, because DP, yeah, like in this contest world or algos and DSA world, people will understand DP, but before I joined and did LeetCode, I have no idea what is DP. So yeah, actually I prefer some readable variable name, not the DP, because DP on its own means just abbreviation, which means nothing in terms of like production code. So yeah, I prefer cache instead of DP. That's right. Thank you. It was a good one. So now optimization. You can spot again that we are using only 2 previously calculated values. We do exactly the same thing. So we do like next, or I don't know, house 2, which is pretty bad, but whatever, and house 1. House 1 is index plus 1, house 2 is index plus 2. And we start working with these variables instead. So this is index plus 2, so it's going to be house 2. This is index plus 1, it's going to be house 1. And that's basically it. And instead of cache here, since we're going to remove it as optimization, our kind of new house 1 for the next iteration going to be a result. But before assigning it, we should assign house 2 because we will lose the value basically. So house 2 equals house 1. Now house 1 equals result. And in the end, we just return house 1 because it's kind of the lowest index. And we want to return the 0 index, which is the lowest one, the smallest one. Actually should work as well. Yeah, but now it's constant space complexity in this case. Great, so let's move forward. Okay, this is but pretty tricky problem. You can try to solve it on your own, but it's kind of tricky in a way, and most of the people here they are voting like definitely not medium, this is not that easy, this should be marked as hard. And when you see it, well, you know what it means. It means that problem might probably be quite complex, right? So let's tackle it. So we have 2 domino shapes, or tiles, whatever it is. So this and this guy. We want, given some space of length n, hello, have everyone who just joined. We are doing dynamic programming here, so join the stream. This is a pretty complex problem. So given an integer n, return the number of ways to tile and 2 times n board. Since the answer might be very large, return it modulo blah blah blah. In tiling, every square must be covered by that. So it's pretty ambiguous description. So what it means in a nutshell, basically. Hello, bro. I see your message. Hello. Night for me, so bye. Have a good stream. Thank you. See the recording later. It's gonna be saved. So what this task asks us to do, basically, given n, so it means we have some space of length 3, and this length is basically 1 this square. So as you can see, only 3 squares can be possibly done here, if we are talking about this small piece that these domino tiles consist of. So given length of 3, this is all the ways we can combine these pieces together to make a consistent rectangle. So what they ask us is to make a consistent rectangle. So it's not possible, for example, to have this situation. Let me draw it. In this case, it's not possible to have this situation. Why? It will be length of 3. This is 1, 2, and 3. But it will not be a complete rectangle, right? This piece is missing here. So therefore it's not included here. From the first sight, the problem might be actually pretty easy because we don't have that much choices how we can put these pieces together, right? But actually, if you think a bit more about the problem, and with the bigger input, what can be happening is the following case. So we have this shape, for example. We have this shape here. Let me draw it bigger. We can have this shape here, and you can have this shape here. And same way, but reversed. So we can have this shape, this shape, this shape, and this one enclosing. And you should count all of this. So if you think that you can just combine, okay, we can get either 3 enclosed without the gap kinda, or we can take 1, or we can take 2 and then calculate them like this, it will not work. So basically how you should model this problem, you should model it in dynamic programming way. So no matter what, you have some space, right? It's space of n. How do you calculate the number of ways you can create a rectangle is that you kind of add in the tiles here and when you reach the end, at this point, if this is the correct rectangle, you add +1. And by the time you're choosing different combinations of how your tiles gonna be grouped together, it basically increases the number of function calls that will go to the end and will add +1. So now, what is the problem? Since we have a lot of combinations like this that I explained, so you might have this one. For example, as a combination, and it will take 4 as a space. You want to basically try every possible tile on every iteration. So let's say you are at index, I don't know, somewhere here. And you might be in which situation? So you might put first this tile, just vertical one. Also, you can put these 2 tiles. You cannot put just one double tile as this, because then like you will leave the gap here, right? So you don't want to leave the gap. So another choice here would be to put these 2 guys. Another choice would be to put this guy and this guy. But then, if we choose to put this, I don't know how to name them. Let's name them as a first, second, third, or no. Let's name it. Yeah, this one gonna be first and this one gonna be type 2. So if we are putting this type 2 pieces, they're gonna leave a gap. So let's say I put first this guy, then I put that guy. I left a gap here, so it means the only possible choices when I'm on this third index, so here, what can I do? I can put a double horizontal tile like this to fill this gap, or I can put another type 2 tile like this and fill the gap completely and finishing it like kinda putting it straight again. Oh my god, connecting the channels. My chat got deactivated in a REST stream chat, whatever. Hey brother, I don't get interest in the essay. If I skip 2-3 days in it, I have to restart it again from scratch. Tell me some hacks, please. You don't get interest. You should get motivation, right? So your motivation might be that get the t-shirt from the LeetCode. Your motivation might be to get a position in some big tech companies, because this is mostly what you target when you solve a lot of LeetCode, right? So let's say you want to get, I don't know, some position at Google, and you know that the only possible way you get a position in Google is when you narrow down your LeetCode problem solving skills, right? So for that you need to grind some number of problems, and I don't know, my feeling is that I'm solving the problem, and whenever I see that I still have some gaps, that I will not be able to solve this type of problem or that type of problem, I feel that exactly this type of problem can catch me on the Google, and I will fail the interview, and I will basically lose my dream work, right? So that's how you should approach it. And with this motivation, you can proceed. If this motivation is not enough for you, maybe you actually don't want to get to Google that much, to be honest, because you need to be honest with you, right? With yourself. Like your motivation should be sufficient for you to continue doing something. If it's not sufficient, maybe you lied to yourself and you actually don't want to achieve this goal. At some point it becomes kind of as a habit, and now I'm getting kind of reinforcement, I don't know, dopamine, endorphin, when I'm just solving the problem and I see this green thing that I solved it, okay, I overcome some challenge. This is kind of confirmation that I can solve challenges, I can solve some problems daily, I still have this skill. It's daily confirmation, and it's satisfying on its own at some point. But you need to get to this point, and you should consistently solving problems in order to have this. So yeah, so basically what we end up with, that at every possible index we might have two situations. Whether we have, let's say we are this index, whether we have straight tile before, so we have 4 choices to put the guys, so we can put this, we can put that, we can put this, and we can put that. So 4 choices basically. Or another case, when we have a gap left by the choice we did before, so it might be this case where gap is below, or this case where gap is behind. It can be also this case. Let me draw it that way. So it can be also that case. So we have this guy, we have this guy, and this is where the gap on top. So anyway, at this point we have only 2 choices to put, because we can close it with tile type 2, or we can kinda proceed with another gap on top by putting the tile behind, below. Thanks, brother. You on LinkedIn, can we connect, and from where are you? So initially, primarily I'm from Ukraine, and yeah, I'm on LinkedIn, and just type this and you will find me. Yes, LinkedIn is basically public, so how do we build our dynamic programming approach? We define our dynamic programming function or subproblem function as how many combinations we can build up from this index, and from having gap or not having gap. So our subproblem would look like this. Get combination, let's say, we would have some index, and if and we have a variable called gap. So whether we have currently gap or not. Actually, it does matter whether the gap is on top or below. So at some point, let's say this was the last one, and yeah, this was the previous index, and this is the current index, and gap might be below, and we need to fill the gap upper. So this kind of situation, and it can be quite a different situation like that when gap is below. So it seems like these are 2 different gaps, but actually you will see later on that it doesn't matter where is the gap. The number of combinations they're gonna spawn from this situation is exactly the same. So instead of spawning 2 different states, we're just gonna spawn same DP, but just multiply the answer by 2. So here it is, how we perform it. So first, base case. If index more than or equal n, we are done. There is how many combinations we can get from index that is out of range already. It's 0. Oh, sorry. No. It's a bit more complicated. So let's say our space is 3. This is our space. When we should be done. So these are our indexes, and length is 3. When we are done. So let's say I put it like that. So I put vertical, vertical, and vertical. And my next call is going to be at index 3 and I don't have any more gaps at index 3. So this is kind of our success criteria, and this is when we should include the current combination as a combination, because if we end it at index 3 with some gap, let's say this guy is looking here, it means it's not a valid combination, because as it's stated, it should be complete, correct rectangle in the end. So if index is equals exactly n and there is no gap, we return 1. Otherwise, if index more than or equal n, we return 0. There will be no combination from this. We shouldn't count this combination. And now exactly our approach. So depending on whether we have gap or not, we will spawn different number of sub-functions. So let's say we don't have gap. So if not gap, what choices do we have? So we can spawn one vertical line, which will lead us to a sub-function on the next index with no gap as well. So our result is equal to 0 initially, and this result is going to be get combination, index plus 1, and false. We emulated now this situation. I will change the color. So we emulated this situation. Now let's emulate this situation. So at this case, we are at index, let's say 1. This is the index 2, and index 3 is here. So in this case, we leave in no gap, but we're gonna continue our computation at index 3. So we stating exactly the same, index plus 2, false. I don't know whether it's a good idea, but okay. Now, what else we can do? We can spawn one of these two guys. It will leave us at index next, which is this one and this one, but it will leave one of the gaps. Since we can do two choices, and two of these choices will lead us to the case when we will be on the next index but with gap, what we are doing is 2 times get combination index plus 1 with gap equal to true. So let me a bit put it together. So yeah, this is kinda how we're gonna organize it. Else, what if we already at the stage that we have gap at current index? Well, in this case, what we can do, again, we have two choices. So let's say we are at this gap. So what we can do, we can spawn and choose tile with the type 2, which will lead us to index plus 2, because this is I plus 1 and this is I plus 2. So we're gonna go here with no gap. So let's express this. So it is get combination index plus 2 and gap false, plus another choice when we have gap is to put the thing below, which leads us exactly to index plus 2 again, but with the gap. So it's get combination index plus 2 with the gap. We return a result in the end. And what we are interested in, our initial situation that we at index 0 and we have no gap. So get combination index 0 and no gap. Let's try run this. It should actually work, but let's see. No, it doesn't. Invalid syntax. Oh my god. So okay, I will rename it to comp, a bit shorter, and I will maybe I would also change index to I, because yeah, it's not enough screen. I want you to see stuff. So it's gonna be I and I everywhere. Is it better? No, I don't think it's better. Yeah, I guess something like that, and you should see it. Anyway, we will redo it. It's all right. Let's run it. Yeah, it should be named as comp. Great. hell? Yeah, I'm sorry. You see, it's fully live. I don't have anything like everywhere, so it's from my head. Let's submit it. It will not pass. It will get time limit exceeded because worst case, we are spawning how many functions from one function call. So in this branch we spawn in 2, in this branch we spawn in 3. So at most, this guy gonna get us O times 3 to the power of n, because at every single call we're gonna spawn 3 more subcalls. Does it make sense? I hope it does. It does. Well, next thing here is to realize the following thing. It's wrong answer. What the hell is this? How come it's wrong answer, man? Okay, maybe I missed something, to be honest. Yes, I think I did. Okay, something here is messed up. Okay, let's check again. So if not gap, what choices do we have? We can put one guy. Yes, we can put these 2 guys. Yes, we can put one of these guys. Yes, or this guy, the other one. Yes, kinda. They should be included, right? Yes. What else did I miss? And in this case, it can be closed. Yeah, this should be actually +1. Yeah, take a look at this. So I will show you the mistake. So with this combination, what do we emulate actually is that we have this guy. Let me actually redraw it. We have this guy and we put this style. Let me draw it as a blue one. And we got this style. And this one is not here yet, so it's empty. So at this point, we were at this index because we had gap, and we are at index +1, not index +2 with the gap. Now let's try this guy. Yeah, now works. Now also one thing I want to mention that we have, we should, I forgot about this. We should do modulo this big number. So let's define our modulo as 10 to the power of 9 plus 7. Yeah, and this is we should apply to every single response. And now I know that, yeah, since our complexity is 3 to the power of n, it will basically get time limit exceeded. So I'm putting cache here for these 2 parameters, and let's run it. Which data structure used in this problem? Well, this is dynamic programming, and except caching, so array or hash map, no other data structure is used. Yeah, it passed now because how did we change our time complexity? So easy way to think about this is how many unique indices and variables gap do we have. So for indices we have from 0 to n-1, which is basically n. And how many combinations, how many gaps do we have? We have actually 2, because it can be either gap or not gap. So in the end it's 2 times n complexity, which translates basically to O of n, because constants are out. So we converted this huge 3 to the power of n to just O of n, which is quite good, quite great. Now, let's do bottom up. One interesting note here, it is put as a DP, one dimension DP, but as you can see we have two variables, which usually signal for us that it should be not a one dimension, it should be two dimension. But I think they just assume that if you have just two values and they constantly two values regardless of how big input I here, maybe that's why it's DP1. So now converting to bottom up. Again, we are putting our cache, some default value, which is, let's put 0. Maximum how we can step from the last valid index, which is n-1, is +2. So that's why I'm initializing this as n+2 length of our cache. Array is used because we're gonna change it to bottom up. Now, exactly same approach. We're simulating our call stack. So we go from I in reversed range n. Also what we want to put here. Sorry, one more thing, that in every, we cannot initialize this as just 0 because every item within index I would have also two branches, whether it is gap or not. And let's represent it with the numbers. So 0 false, 1 true. Instead of here, we would initialize array with the length of 2, like that. And now what we want to say is when I is equal to n and not gap, we should initialize base case as 1. So this is what we are doing. So cache of n and not gap equals 0 because it's false. We put 1. Everything else remains 0. Now we have our gap in range. So I would do just to simulate exactly the kind of call stack, but it's not necessary to do for loop here. So gap in range 2, so it's going to be 0 and 1 only. Now what do we do here? So exactly same as we did before. These base cases are not needed anymore because they are expressed in our cache already. And what we do, we just copy our top-down approach, put it here. And now we change the function calls to the array access, so array call, whatever it is. So I would rewrite it. Just check the hands. So instead of combination, it's going to be cache I plus 1 and false represented as 0 plus cache I plus 2 false as represented as 0 plus cache I plus 1 true represented as 1, else result equals to cache I plus 2 false equals as 0 represented as 0, or cache I plus 1 1 for the true. We drop our bottom up, exactly simulated the same call stack, and then we return, well, we don't return in this case, we just put in cache I gap equals to this result. And then, as usual thing, we change this function call also to accessing our cache. So we return cache with index 0 and false because we start without gap. Now let's check whether it works. No, it doesn't. Okay, so let's see what is going on here. Let's check what is going on here. So did I initialize it correctly at all? Just wondering. Yes. Wait. This should not be. Oh, I think this is Python thing. Maybe this array. Yeah, exactly. So Python actually optimized it and put exactly the same array. So whenever I'm changing the value in one array, it changes basically all of them. So that's why I have this picture. And I think to fix it, what should be done is the following. For range something like that, no? Yes, now it is expected. But why our bottom-up doesn't work on this input, so we're returning less value than actually we should. Let me double check. So false, true. Yeah, we forgot this 2 times because, yeah, sorry. It just didn't place it correctly. But yeah, in general, just copy-paste top-down approach and a bit slightly improve it to have a bottom-up is pretty viable and working approach. So in this case, even this pretty hard problem is getting solved like this, easily. Now, can we improve it further somehow? Well, since it's 2-dimensional array, at that point it's a bit hard right now to optimize it even further, but you can clearly notice that we're also using only previous and previous before previous calculations of our subproblems. We don't care how many ends there were before. So to optimize it, we basically need to carry this guy with index +1 and this guy, and that's it. So let's try to optimize it. So I don't know, previous 2 we're gonna initialize as 0, 0. You remember this array, so this would be previous 2, this is going to be previous 1, and we're going to start calculating from this guy. So pre1 equals 1, 0. Now we remove our cache completely. And what we're going to do here, so exactly the same, but instead of this cache, we're just changing the things. So I would put current as this guy, and now yes, so for I +1 I'm putting previous, like that, and previous 2 I'm putting for cache with index I +2. So it's pretty formal, pretty, I would say, in a way boring. Now we should again shift these constant variables of our dynamic programming solution instead of these things. So what do we do is prev2 becomes prev1, prev1 becomes current. And this is going to be current sorry, so current gap, exactly, and this guy should be in outer loop. Yeah, so pretty much should be working. Let's check. Oh shit, we don't have this cache. Should return actually prev1 with 0. Should just with 0 because false. yeah, should be working, and with this approach we actually saved a lot of not money, but just space complexity. Now you have just two constants because it's just two arrays of length 2, and this length 2 is length 2 regardless of the length of the array, so that's it. Yeah, I think today's session was pretty good already for the dynamic programming understanding. Also, we got a bit lower amount of people right now. So yeah, how many? Yeah, we're already doing it for 1.5 hours. So let's switch to system design topic at this moment, and yeah, we will continue further with two-dimensional dynamic programming next session, right? Good. So that's how is it going. This is how you do the basically dynamic programming approaching. So recalling 4 steps: define a good subproblem, write a recursive subfunction for it, add memoization, convert it to top down, then convert it to bottom up. Now maybe let's talk quite a bit about consistent hashing and how it helps, how it's gonna be scaled, for example, and how it works. So whenever you see or approach system design question, right, you might have some concept as scaling the storage, any type of storage, usually databases like SQL, NoSQL databases, and in that case, yeah. So what is the problem with the scaling? How would you scale? So what you usually do, and this is pretty much described here, this designing, yeah, in this beautiful book. Please read it because this concept is explained here. So how can you split the scene? So basically what you can do, consistent hashing over here. So if you don't have consistent hashing, how you can split? So you have some amount of data and you have some database, I don't know, you have some database, and this database handles range of all your data from 1 to n IDs, whatever it is. Now you understand that you have too much data. So one instance cannot handle it, and not data-wise, but load-wise. And the load might be write load as well, not only the read load. So just replicating and spawning read replicas might not help here. So what do you do in this case? You can actually split this database into different instances and say that, okay, this instance is handling from 1 to n divided by 2, and this instance is handling n divided by 2 plus 1 to n, basically. How you can approach this? One way of approaching it is just basically getting key. So let's say you have not a universal ID, not this GUI ID or UUID, but instead you have just primary ID as a number. So it goes this way as a regular primary key in the database. So what's the problem is here? You can define that actually you have these IDs, and whenever you create or request a new row in your database or new document, whatever it is, you just check this ID. So if your ID is more than n divided by 2 plus 1, more than or equal, in this case this ID would go to this instance, because this instance is handling the right half of the data. Otherwise, if ID is less than n divided by 2, or let's put this boundary, it goes this way. to the, I don't know, let's name it shard1, shard2, and let's put, I don't know, some blue one. This is one way of doing this sharding, and following this thing, you right now have this approach that you are writing IDs that are higher here, and these IDs that are lower, they are handled here. But what will be the problem, that if your system is write heavy, so you have more or equal amount of writes, it will not help, because all your new data is going to be a new number. So if I want to create some new row somewhere in your database, my next number would be actually, so my new number would be more than or equal than current n, which means it will always be going here, which actually doesn't really solve our problem. It will be pretty much same like having a bunch of read replicas, because all the IDs that are less than this number, they are going to other previous shards, right? So these previous shards, they're gonna have only read load, and only the new one gonna have write load, and also read load, because somebody wants to read this key as well, right? Which is quite bad, How to overcome this? So instead of, let's say you have this primary ID, so instead of sharding like that, you can leave same thing like it was before, but now you're stating that your partition ID or shard ID, whatever it is, shard ID is going to be hash of this ID modulo number of instances, which is 2, because I have 2 databases. So whatever hash I have, this is, I think, 32-bit number, so 4-byte number. Whatever it is, it will be mapped basically to either 0 or 1 as a set of possible outcomes. So now, whenever I'm creating new ID, it's not always going to go to shard2, but also it might go to shard1. But now the problem that I have, these ranges are not true anymore, but let's say I want to introduce another shard, shard3. Now what will happen? So let's say here I had numbers IDs 1, 5, 6, 7, and here I had numbers 2, 8, 9, and let's say 4, right? Yes. And now I want to split these 2 databases and shuffle some data to shard3. If I put it like this and leave a modulo operation, what will happen? We can do odd keys in first shard and even keys in second shard. Yeah, this is exactly what will be following from this hash function, but well, without hash function, right? Instead of hash function, you can just have ID modulo 2. It will be pretty much same result, but there is still a problem, because now you cannot easily scale if you think of that. Okay, let's actually do a real one. So let me spawn my Python. So we're gonna decide right now what will be for this key. So 1 divide modulo 2 is 1, 5 modulo 2 is 1, 6 modulo 2 is 0, 7 modulo 2, 1. 2 modulo 2 is 0, 4 modulo 2 is 0, okay, this one is easy, and 9 is gonna be 1, right? So let's actually shuffle it according to real world scenario. So what we're gonna have, I just want to rewrite it again. So shard1 is going to have 6, is going to have 2, and it's going to have 4. Even numbers, pretty obvious, right? And this guy gonna have all uneven numbers. So let's say this guy's over here, and maybe, I don't know, 10. Now we are introducing new shard, and now modulo becomes not modulo by 2, but modulo of 3. And now let's try to redo same thing. So what is going to happen? 6 modulo 3 is going to be 0, it leaves there. 2 modulo 3 is going to be 2, which is this shard. So I'm gonna write it as a new one. So 2 is going here. 4 modulo 3 is going to be 1. So 4 is going here. 10 modulo 3 is going to be 1. It's going here as well. Now let's do this one. So 1 modulo 3 is going to be 1. All good. 5 modulo 3 is going to be 2. Again, 5 is here. 7 modulo 3 is going to be 1. Leaves as it is. And 9 modulo 3 is going to be here. So here's going to be our 9. I think I'm missing some numbers. Okay, whatever. So yeah, 6. Sorry, I would add it. So new keys that will be here. So 6. Yeah, 2 will not be here. 4 will not be here. 10 will not be here. So 6, 9. This guy gonna have. So 1 modulo is gonna have 1. It's gonna have what else? 5. No, 2, no. 7. 7 modulo 3 and 9 modulo 3. Okay. So it's gonna have also 7 and 9. Now check this out. The point of all this speech was. This was the previous ones. These are the new ones. After we introduced the new partition, what happened? That actually a lot of our keys are going to travel to different shard, and like mathematically it is proven that it will be like quite a lot of keys resharded, I would say, which is bad. And why is it bad? Because now you should have some migration, right? Because right now if you want to get ID 1, if you want to get, let's say, ID 4, and previously ID 4 was in shard 1, this data was in shard 1, but now ID 4 will lead you to this guy, which doesn't have this data. So you need somehow run some tool which gonna reorganize the data from mod 2 to mod 3 scenario, and that's basically how it will be. Not only it will increase memory consumption a lot, because you're gonna, like during this migration, you're gonna hold a lot of new keys, but also it will increase a lot of CPU load, and what is more important, it will increase a lot of like the time that's spent during the resharding, adding or removing one shard, which is very bad, because usually when you scale, you want it to be scaled as soon as possible, because probably you have some spike or new traffic or whatever. So it is a bad approach, and it is pretty much explained the same way in this Martin Klapman's book. What is the consistent hashing and why it is working? So consistent hashing, how is it working? That, yeah, you have something called circle, and you kinda circle, but also easier to understand this circle would be if you just flatten it to the number line. This is gonna be 0, this is gonna be some number, and what you assume and what is your structure, that you put in nodes that are going to be your shards. You're putting them randomly, and you're stating that actually, let's say this is shard 3, this is shard 2, this is shard, or let's maybe do with 2 shards, our initial situation. So you're stating that this space is handled by shard 1, not only this space but also this space as well. So this is shard 1 and this is shard 1, and this space, let me draw it different color, this space is handled by shard 2. Now, why is it better than module? Because now when you want to let's say reshard, how you do it? You're gonna define additional shard. I don't know, let's say randomly it happened to be there. And all this space is basically how you hash the key. So you still have this hash from your ID. And this will give you some number. And this number is basically this space. It lies somewhere in this space. And also the partition gonna have its own number. So I think this is clear. Now when you do this new shard, what happens? This shard lies on the space of shard 1. And how do you split now? Well, pretty easy. Shard 2 is not touched at all. Because you have this concept that whatever is previously up until previous shard is handled by current shard. So now I'm stating that this space is handled not by 1, but by third shard. And I'm removing this guy, and I'm stating that right now the green shard or the first shard is handling only this data. And in order to do this operation, you just need only to shuffle this part of data to shard number 3 and remove this part of data from shard number 1. Or you might not even remove it from shard number 1, it will be just unused. You just remove it to improve the things. But in general, you don't even have to remove it if you have enough disk space on this shard. And it ensures if you scale it more, for let's say you have 100 of shards, and when you reshuffle 100 of shards with this modulo, it sucks because yeah, you're gonna reshuffle all of them. It will increase load and it will take infinity to do this. But with this approach, you can basically scale and touch only single node, this node, and only half of the data in this node. And this node, you might not put it into rotation, you might do it with it whatever you want. You can 100% CPU load with write requests, right? This is what you can do. There are still some problems with consistent hashing. Like for example, let's say you got these two nodes here and they are overloaded. How are you gonna split further? Right, so, or this situation. How are you gonna split this node? This is a problem. Also another problem here that let's say you don't have just one node you want to split, but you have high CPU and I don't know, high load, high memory consumption, whatever, in all of your shards. And then resharding just one instance helps you only with this one instance. So let's say I had 80% CPU on every single node, right, that I have, every single shard. And if I split only this guy, I will split to this situation. So I'll have 40 for new one, and this remains 80 still, right? So it will not help a lot. So that's why different storages have even different approach. For example, Redis, I don't know, partitioning. It uses hash slots. So how do they do it? Yeah, they have this amount of hash slots in Redis cluster, and they compute hash slot for key, and they are taking yeah, pretty much very similar to this partitioning approach, but they straight away defining this number of nodes. And they define that, yeah, you cannot go further. So if you already have this number of shards, you cannot scale more. And what they do, that they have every single node to handle. So this is, let's say this is Redis. It might have, I don't know, 500 slots. And this guy might have, I don't know, 1,000 of slots. And how do you scale? You just move some of the slots from here to another Redis. And you just basically have these ranges of slots on your machine. This is how Redis operates, and it's kind of solves this problem more accurately because you can more evenly split the data. You don't have to split it at half, right? You can kind of control how much data you moving between the nodes. That's basically it. yeah, I don't think we have time to implement this scene once again on memory. Let's do it the next stream because we spent quite a lot of time on the dynamic programming. So what can I say? Please don't forget to subscribe on my Telegram and Instagram. This is very important. We're gonna stream next time as well. I think next weekend. And yeah, I think this stream was quite useful. Next week we're gonna implement consistent hashing, or maybe I will come up with some another idea. So I want to write a bit of POCs and implement a bit of POCs for system design solutions that we implemented, basically to follow up on this repo. Yeah, and we're gonna continue with dynamic programming later as well. Then we had a bunch of other things we are going to solve as well. So yeah, that was me, Andriy. Thank you so much for participating, for being with me. It was nice to have you, and yeah, see you later, guys. Bye bye.